Hello and welcome to Partially Redacted. I'm your host, Sean Falconer, and today I'm joined by Jack Godau, most recently CDO of Doctorly, and we'll be discussing pseudo-anonymization. Jack, welcome to the show.
Hi, thanks so much, Sean, for having me. It's a great pleasure to be here. I think this is an important topic, this anonymization, privacy. All of this is what's going to make or break things that are happening in the future. So I think this is really cool.
Yeah, absolutely. Yeah, I think we'll cover a lot of different things today. Maybe let's start with an introduction. Who are you? What do you do?
So as you said already, my name's Jack Godau. I have been doing IT for an incredibly long time, hair color. So I've been in this for about 30 years. I've been doing a lot of government projects, I think secret, like schools, kindergartens, like healthcare, things like that, which are very much privacy focused. And that's been a big drive for me over the years. Originally, way back when, software developer, much more recently, leader of organizations. So it's been a progression over the last 30 odd years.
Yeah, fantastic. Like it seems like, kind of, based on, what you said there in terms of, work, you worked with a lot of, like schools, healthcare, things with the government. You've kind of, made a career out of engineering in highly sensitive spaces, like highly sensitive data. Like, was that by design or did you kind of fall into it? Like, why take on like the burden of responsibility of having to secure things like that?
I did fall into it. And so, look, I moved to Germany. I lived in Australia for 30 years, moved to Germany, took a job. They happened to be doing stuff around kindergartens and schools. Then I landed some government projects around healthcare. We built the German National Transplant Registry, for example, and similar things. And it turns out now that I don't want to do anything else. I enjoy doing something that's useful and meaningful. I use Amazon, I use all these other things, but I can't bring myself to build a product that sells another shoe, right? Like it's just not me anymore. Once perhaps, but not anymore. So it's interesting how things change over time.
Yeah, and I think there's also always hard problems, hard engineering problems, hard design problems to kind of tackle in that space. Probably keeps it interesting.
Yeah, and I think for me, like all of the systems I built, while they do deal with massive data sets, it's nothing like the scale of some of these bigger companies. But in terms of the requirements around privacy, around security, around all of these topics, they're incredibly more restrictive than the business case. Like if you're working in business, somebody like you sign up to Facebook, you agree to their terms and conditions, they do whatever they want with your data. Here, especially in these fields and in Germany, which is super privacy focused, it's just not like that. You can't get away with the things that you can get away with in business.
Yeah, yeah. So how does working with this kind of sensitive regulated data, in particular, probably in the the regions that you live in Germany as well, like how does that impact the way that you have to approach engineering?
Privacy and security become first-class citizens, right? And I've seen it in other spaces where you build something and then afterwards like, oh, we should worry about how to keep it safe, or we should worry about data privacy and protection. Maybe we should encrypt people's credit card numbers. Like this comes as an add-on. Whereas in these fields, like especially government tenders in Germany, you can't win these tenders unless you can comply with these security regulations, and they have a whole list of requirements that they demand of you to say, okay, how are you going to deal with this? How are you going to deal with this? And I think it's really positive actually to see these things as not an afterthought, but as a first class, look, this is a real requirement of real software. It has to be there from the beginning. That's I think the main difference between we're building some app, we want to see if it sells and then like go out and expand and tack on, or do we start from this very, very secure place?
Yeah, I mean it's kind of the difference between you're buying a car and there's no seatbelts in it. And then you decide, okay, well, maybe, now I should put seatbelts in it because I'm, driving too fast or something like that versus, putting those seatbelts in from day one and assuming that it's probably a good idea to make people have seatbelts.
It's a super example, really funny actually, because I did that because I had a 66 Ford when I lived in Australia and didn't have seatbelts. And then I got kids. And I'm not putting my baby in the back seat without like a baby seat and a seatbelt. And so then I'm like talking to engineers about where can we weld things onto the bottom of the car, and it's very complicated. So it's a very apt example.
Yeah, exactly. So, the does this create like the fact that it's sort of a priority, first day priority? Is there any tension between, I guess, like seeing this as a barrier to innovation? Like, hey, I want to be able to move fast, but if I have to think about this stuff up front, it becomes a limiting factor to being able to move quickly.
It is, and it's unfortunate too. In Germany, there's a lot of data protection officers. We have the national ones, we have the state ones. There's ones like in different companies. These people are very often, unfortunately, in a losing position. They either get to say, no, you're not allowed to do it, or it's their fault when the data goes wild, right? So they're not in a great position. And there's a new person who's come into this role nationally now who I have more hopes for. But the requirements they put on things are, in some cases, unreasonable and unrealistic. We did e-prescription, for example, in Germany. If your doctor mails you a postal prescription, it's considered safe because you've licked the back of a piece of paper and put a sticky note on the front. And that's safe because in Germany, there's a law, or other countries too, like postal secrecy. You're not allowed to open other people's mail, right?
Right.
The digital equivalent of that was the doctor has to put it in a safe to which he doesn't know the combination. 2 armed guards carry it to your house, and then you have to blow it up to be able to get to your prescription. It's like, this is like, it's not the same. And I do understand it's easier to steal something in the digital world, of course, but we've been doing online banking for God knows how long. And like, how often do people steal from your bank account, right? Like, not very often, if ever. So there's this mistaken belief of adding extra layers and so we'll encrypt the file and then we'll send it through an encrypted channel. Why? Right? Like, there's like some of the one of those two things is unnecessary.
Yeah, absolutely. Yeah. I mean, I think that, I'm a firm believer in the idea of privacy security sort of day one, but I think
Yep.
sometimes we're not doing ourselves any favors by like overcomplicating it in the, one of the challenges with making something like overcomplicated is that's when it leads to sort of, shadow IT situations because
Yep.
it becomes like, I can't do my job because, I can't access this information, or I can't do my job because I can't access the system. And people come with creative ways essentially to get around that, which defeats the purpose of putting those security controls there in the first place.
Yeah, absolutely. And there's a lot of I refer to it as security theater, right? There's a lot of this. We do it in airports. Like, there's all of this like show and tell about how secure stuff is, but there's a back end supply chain that you can get through and around. So like, yes, the stuff at the front protects you from the lowest class of idiot who's trying to get in. But if somebody really wants in, and even the systems that we built, if the NSA, the CIA, the Israelis, the Russians, if some of these really serious people want to get in, they're in, right? Like, you've got to deal with that as well as a concept, not just how do we keep people out, how do we keep it secure, but what do we do when it happens?
Right. Yeah. You do that. You kind of have to have that assumption that if someone's determined enough, they could get in. But then you can also, if you accept that, then you can think through what is the scale of that impact and how do I react to it and stuff. And that's a much more sort of proactive approach.
Yeah.
Yeah. So we're talking pseudo anonymization and just kind of help set the right context. Like, what is pseudo anonymization and how does that differ from something like full anonymization?
So full anonymization, by the legal definitions we have with the GDPR, full anonymization, you can never go back to the original data. So the data is so mixed up that or so changed that you will never find the source of it. That's in a lot of cases now, especially with computing power becoming very available, high power computing being available, it's almost unrealistic. So pseudonymization is the definition. It's unreasonably hard to revert back to the original data set. So, for example, changing names around, like changing dates of birth around, but not changing all of the facts of the record. That's pseudonymization. It's like putting on sunglasses and the funny nose. It's still you underneath. Somebody can work out that it's you if they're smart enough, but at a reasonably cursory glance or even at a semi-detailed inspection, they won't know.
Mm-hmm. And is the idea there is that one is doing full anonymization is too complicated or not possible under certain circumstances, or does it, if we did that, it would break certain like workflows and use cases that we essentially need to support. Like we're not collecting this data just for the sake of collecting it. We're collecting it
Yeah.
to like do something with it. So you need some way to still do something with that while also keeping it protected.
Yeah. So full anonymization, the data is then for any kind of analytics, any kind of processing afterwards, it's useless. It may as well just be random, right?
Mm-hmm.
And especially in fields like schools and kindergartens, the marks that certain teachers are giving out, while the individual students are not relevant, but how is this class being marked compared to other classes? Relevant. What are people paying for education? Healthcare, medical records. You can't do any kind of medical research on anonymous data.
Right.
Like you need the actual blood test results for the numbers. If you have a few of those, you'll be able to find that individual if you really put your mind to it. Right? Over time, people's blood tests don't change that much over their period of years.
And how does pseudo-anonymization comply with regulations like GDPR?
So GDPR explicitly says that data should be like so. Firstly, it says that data can only be used for the purpose for which it's collected. So you can't collect data to say, all right, the doctor's collecting data to treat the patient. That data cannot be given further to a research institute to use it unless the patient consents. So there has to be this explicit consent first, and then only the minimum amount of data that's necessary has to be given. So for medical research, you don't need to know where they live. Like if you're researching blood clots in men of 35 to 45, you don't need to know if it was John, James, or anybody else. You just need the actual data of the test results. And then ideally, even that should be converted into a format, so pseudo-anonymized, so that it's not possible to go from this lab result and then to look in a doctor's files and go, okay, that was that lab result, so I know this was John, and then I can jump to the rest of his medical record from that.
Right. Yeah. Yeah. We've seen, some companies, for example, get in trouble for like phone number abuse, where they collect the phone number for maybe for 2FA, but then they use the phone number for like a marketing use
Yep.
case, for example. Like that's a big
Yep.
no-no. And then I think a lot of times, like around your point of, you know, using the minimal amount of data and performing some of this like secondary analysis, like I think a lot of times we convince ourselves as an industry that we need more data than we actually like required to do the job. Like if you think about the kind of secondary analysis that you're doing in a medical situation, like it's a lot of times going to be about the test results. You don't necessarily need to know the individual, the person. You're looking for trends over
Yep.
aggregates of data, not individual people, persons. Right. So like, why is someone's, home address in your warehouse or their, phone number and stuff? You're putting sort of an unfair burden on the team that's performing the analysis to make sure that they don't leak any of that data.
Yeah, and things have changed over the 30 years that I've been working. At the beginning, disk space, memory, all of these things were really expensive. Compute was expensive, and you kept only what you absolutely needed, and you tried to keep it small, which is why we had the whole Y2K thing, because we only stored 2 digits instead of 4, right? Like, it's not always a good thing, right? But over time, when this stuff has become exceptionally cheap, people have gone to the other extreme and have gone, let's keep everything just in case. And in a lot of cases, it's often not looked at, but it's still lying around somewhere. And that's a big risk. If you're storing stuff that you don't need, that you're not using, and that you maybe are not even supposed to have, the question is, why are you doing that? And what's do you need it, and can you get rid of it before this ticking time bomb goes off somewhere inside your organization?
Mm-hmm. Yeah. Yeah. And if you look at some of the, the breaches that happened recently from compromised credentials for, into like Snowflake and stuff like that from places like AT&T and Ticketmaster, there's like call logs, there's, credit card information. Like what is the business use case for having that in your warehouse in the first place versus like, I'm sure that, maybe they're doing some kind of secondary analysis, but like, do you really like what is the business use case that like someone on the analytics team or the data science team needs to see someone's credit card information? Like there's just not one.
There isn't. And if you're trying to, like, if you want to keep the credit card numbers to prevent fraud, like, are there too many purchases coming from the same credit card from different places? Hashing, like, you don't need the actual credit card, like, and it's cheaper to store hashes of data usually than it is to store the full data set, right? Like, you can store a hash of like a Windows CD, like in like 64 bytes. The Windows CD takes 1.5 gig, right? Like, so I think people they just don't think about it. It's not an important enough requirement. And people are like, all right, so they enter their credit card on the form, they enter their name, their address when they sign up to our webpage, our shop, whatever, and it just gets saved. It's the default now, like whatever's entered gets saved. And that's in Germany and Europe with GDPR, that's technically illegal. If you have no right to it, it is a breach of GDPR and various national legislations across Europe.
Mm-hmm. In terms of pseudo-anonymization, like what are some of the like techniques to make something pseudo-anonymized?
It depends what you're dealing with, right? And it depends the granularity that you need. So you can either change things completely. So we could swap names, right? I could become Jack Falconer, you could become Sean Godau. That would be a form of pseudonymization. It's not very good because in a small population, you can get it back. If there are things that are relevant, for example, if you're dealing with children and schools and age, you still need their year of birth, but you probably don't need their day of birth. So you can just put everybody to the 1st of the month or the 15th or a random day in the month. Phone numbers, like for any kind of pseudonymization, if you're calling them back, you need the real phone number, right? If you have a genuine need to talk to these people, you'll need the real phone number. If you're using the data for other purposes and it just has to exist, then you can just throw random numbers at it and generate in this way. So it depends what you're trying to really do with the data afterwards. And I think that's the important question to ask first. What are we doing after? And then you can talk about how do we make it compliant and match.
Right. Yeah, and realistically, if you kind of have like an application stack with a transactional layer, and then maybe you have like an analytics stack that you're using for analysis and data science, like there's going to probably be different people and different services that have different uses of that information. Like a person probably doesn't necessarily need to see someone's phone number, but a service might need to see a phone number in order to do send a text message or interconnect on a phone call. But the analyst might need to know the country code in order to do some sort of grouping of that. So you have to think through what are those use cases. And then ideally you have a system that essentially allows you to flex dynamically between those different situations.
Yeah. And that's also like, are you in a system where you're pseudonymizing the data and you're then processing on this pseudonymized stack? Or are you making live requests to data and getting different answers depending on who you are and what permissions you have and what purpose you're accessing it for? So those are two kind of different approaches. And I've seen both done and they both have their place in the world, but it really depends. What are you doing?
Yeah, absolutely. I know you've written some papers on this topic and you built, some of this technology at companies you work for. Like, what sort of take me through that? Like, what's involved with kind of like trying to build something like this in order to support these different use cases? You have requirements today, but those requirements could change down the road.
Yeah. So the first time we did this, and this was mid 2000s, so 2006, 2008, roughly, and we have a huge database of, or the production system has a huge database of all the children in Berlin, where they go to kindergarten, how much the parents earn, so how much they have to pay, how much the state then pays to the kindergarten, all of this stuff, like huge body of records. And as the system becomes more complicated, we're getting more and more bug reports. But we can't reproduce this. There's certain constellations in the data where it's just like, all right, but it seems to work. The tests run, everything looks okay, but obviously it's broken. And then at that point, there's engineers who are at some point looking at the production system to try and work out what's going on. That's never really a brilliant idea. And so we say, okay, we need a copy of the data, but we can't just take it. So then we built, actually, the first versions were really complicated PSQL scripts running in an Oracle database that would mix the data up. So it would, all of the dates of birth went to the first of the month. All of the addresses went to like house number 1 and some generic street. The postcodes stayed the same because the postcodes were relevant for where they lived. And so there was like thousands of lines of PSQL custom written code, super fragile. Every month when we're trying to take a dump of the database, somebody would change something in the production database or like as building new features, and then the pseudoanonymization script at some point wouldn't run. And then you've got to debug that. Horrible, right? Absolutely like not tenable. And it took a lot of maintenance and it caused a lot of effort. We moved on from that and to build kind of a processing engine that ran on a Kafka queue. So the data was there and you could kind of scroll forwards and backwards through the data. And then you would run different operations depending on, all right, this is an address. We want it to stay in the same postcode, the same street, or whatever. You could kind of tweak it. But it was a lot of custom built stuff because back then there was nothing out there. You couldn't buy this off the shelf. We weren't running back then. There wasn't an Amazon cloud or a Google cloud. It was all like run locally in data centers.
Mm-hmm. In the Kafka streaming sense, were you using something like Flink to do the processing? Like, how were you essentially observing the streams and then converting things to pseudo-anonymized?
We were a Java shop, so we did a lot of stuff in Java, and then eventually a little bit of stuff in Kotlin. And we just had like listeners that would listen to certain types of data.
Got it.
So the data would get pumped in, it would be augmented. This is an address, and then the address. Oh, this is an address. All right, process this way, spit out this. Also not great, but if you go back to 2006, the things that we have now simply just weren't there, right? Like so, like it was a lot of like manual. How should we do this? What do we need to do about that? Do we even need this data, or can we? So all PDFs got replaced with a blank page, for example.
Yeah, so the original sounds like the original use case for this was essentially getting a version of the data that you could do for local non-production testing, essentially, where you could figure out like what are the bugs that we're having in production, but you're not testing directly against production data.
Testing and also development, because behind all of this, there was a big data warehouse as well that was being built and constantly built upon. And you have to build these analytic tools and processes and build these like data cubes to run the reports on. You can't do that without a certain volume of data. Of course, you can generate random data, but it's not the same as the data that is really in existence. So this is like, and it's still a very valid use case. Like you want to test your systems, you need real volumes of data. You can't use the real stuff. If you make it up, it's just not as diverse as you find in a huge population of real data.
Yeah, absolutely. What were some of the like key components of this engine that you eventually built, and like what were some of the most challenging parts of it?
So the really challenging parts were there's obviously interrelations between the data, right? So if you have a child of a certain age and parents of a certain income, they have to pay a certain amount. So you can't change those factors because otherwise, if you copy the data into the test system says, look, this is wrong. Like they should be paying less. And so you have to build these. The simple one is I want to change the address. So so you change it to like a random street name, keep the postcode, pick a house number, doesn't matter because it's not used anywhere else. But once you're using stuff in combination, there's a contract for a child to go to a particular kindergarten, the parents pay a certain amount, government pays a certain amount, there's like billing cycles. So you need to build these consistency into it. And that's where it became much more of a challenge to build these like message processing services that would not just process one message, but find that message and then go, I've got this message, so I've got to find another message. And then those two things, or those 12 things, or those 24 things have to be processed together so that afterwards they still make sense.
Right. Yeah. Absolutely. We have a customer at Skyflow that has like specific requirements around essentially like doctor's visits. So this is just one example, but they're processing things like information from a doctor's office, and they need to make sure that they're not retaining the date of the visit, because then that would be a way to like trace back at least a small set of who those people are. But they need to preserve the delta essentially between multiple visits. So I need to know that these happen 10 days apart, but I don't want the actual original dates. So very, very specific requirements for those kind of use cases.
Yeah, and it's a similar thing, right? You need this consistency, and obviously the stuff in that case, the stuff that happens in one doctor's visit should remain in one doctor's visit, and shouldn't be mixed with other visits from other patients or that own patient himself or herself.
Yeah. Otherwise, you're going to destroy. Like if you're doing something in AI, you're destroying the model to integrity. If you're doing something just in analytics, then joins and aggregation of data and analysis is not going to work. Or even if you're in a testing sense, like the test is going to fail because
Yep.
the data is now fundamentally different. So, what was the scope of some of building these this kind of like pseudo anonymization engine, and how much time, like how long to MVP essentially?
And this was basically two people's job. They did some other stuff as well, but I would say like two people, 70%, this is all they did. Yeah, and so that it's a huge drain. Like, especially in the early days. Later on, it became a bit better because then PLSQL is something that not every developer does, right? Like, especially not these days.
Yeah.
Java, at least, then we had a bigger pool of developers. We could spread the work out across. And then when people built something new, they were responsible for building the new bit of pseudo-anonymization themselves. That worked a lot better, but it was like, it did take, and two people. What was the team size back then? That might have been 5-6% of the team was busy just doing this.
Mm-hmm. Yeah, and it's not like it's a project that really has an end. It's like a project that's going to go on forever. Besides just like the maintenance, you're going to have to do updates all the time depending on new data sources that you're collecting or new types of data you're collecting.
Yeah, and that was the biggest problem. Like the whole construct becomes very fragile. One change here and it has a knock-on effect. If you didn't think about, oh, this data is also used in this joint process somewhere else, then that's suddenly not working. And people are like, but I didn't touch anything over there. So you have to work out which input it is out of the 12 possible inputs that is now like gone janky. It's not something that I would really like love to do again, to be honest, from this point of view.
Mm-hmm. How did you handle like the re-identification risks? Like, what measures did you have to put in place to prevent something like that?
I like if I turn up at conferences or at events where we talk about this, I usually play this game where I ask like kind of 5 or 6 questions to the audience, make everybody stand up, and then I'm like, all right, who's got a dog? All of you people sit down, and then like who's got a cat? And you like within 5 or 6 harmless questions, there's one person standing out of a room of like 200, 300 people. If you get the questions right, you can do it fairly easily, and people don't realize that it's so easy from random data to really go back. So in those cases, in some cases we have to run over aggregation. So we would, if there's a population, we would take 5 records and they would just become one. So you just mash them together. There's obviously side effects of this kind of thing, but if there's one person who's given birth that week in some small country hospital in Australia somewhere, there's no amount of changing that person's address that's going to change anything about finding them again, because it's the only person who went to that hospital and gave birth that week. So in those cases, you either have to wear the risk, or you say, okay, if there's populations that are too small, we're just not going to take the data across. We'll just drop it.
Mm-hmm. Were you doing anything around like using the mathematical model that like differential privacy gives you to measure like what is your, how sort of differentially private this system is?
We did some of that later on, certainly towards the time where we're doing things like the National Transplant Registry, in terms of, because here again, data has to be matched from different sources, you have inputs, and then you want to be able to find things within that pseudonym. So you have a mathematical pseudonym, and you have processes where you can kind of say, okay, that matches to this pseudonym, even though I don't know who that is. So you can do some very complicated mathematical matching, but that was very late in the game.
And was there trade-offs between essentially meeting certain performance requirements with the level of sort of an anonymity you can guarantee?
So with these medical registries, it had to be right. So for the medical registries, there was a bunch of hashing algorithms that stuff was run through with very large salt values that were unknown to the outside world. So we would effectively hash stuff multiple times using different salt values, and that became the pseudonym. But that was done segregated per medical process. So if somebody gets a new heart and somebody gets a new knee, those two data sets generate completely different pseudonyms. So like technically there probably is some medical correlation between the heart and the knee, but in terms of like monitoring the transplants and monitoring the implants, there was no need for that. So that was very strict in terms of the stuff we did for the kindergartens and schools. And that was basically, we were taking copies of the production database for us to build the system. And I know that this, like, overall, this ran for 4 or 5 days. We ran it once a month, once a quarter, and that was fine, right? So there was no live feed out of the back of it. There's no performance requirements. The medical registry stuff, that has to go in, data comes in, data goes out. But that was also like, I think it was like, it had to be processed within a day. So there was no big deal about that.
And then, did you ever have situations where you need to re-identify any of this data at some point, or is it strictly a one-way pseudo-anonymization?
So these medical registries are actually built in a way that you are then able to re-identify in certain circumstances. And in those cases, obviously you can't use hashing, but then the data, certain sets of the data are put together, salted, and then encrypted with a specific encryption key that only this trusted third party that we ran had access to. So, and then if the government authority comes and, all right, we need to know what's happened with this transplant, we need to contact the hospital, then there's a certain request chain where they can issue a formal request and say, okay, this data has to go back to this hospital. And it doesn't actually even go back to the person who requested it. It goes back to the hospital that the transplant was done at. So the government authority requests it, but the data goes back to the hospital, which actually has the real data anyway. It's just a way of getting in touch with them and saying, hey, like, you guys need to like look at this more closely.
Yeah, got it. Do you think, would this be something you would ever want to build again?
This wasn't too bad because it's effectively like it's an encryption run across a few sets of data, and then you've got to be careful that nobody gets access to the keys. So that wasn't terrible. I don't think there's a real, and there's very specific needs for this. So I think ideally a lot of this stuff, I think it makes sense to outsource in the same way that these days, most of us use Amazon or Google Cloud or soon Lidl Cloud potentially to run our services, because we don't want to have to care about keeping this stuff up to date. We don't want to care about which algorithm it is that's now no longer compliant. At some point, we're going to have to get into quantum safe algorithms. That's going to be a big change for everybody. Everything that's now encrypted and completely safe might, in some point in the future, not be. I mean, there's going to be a big need to change all of that data over to a new encryption. That's going to be a big thing. I think it makes sense to leverage tools that exist. And I think nowadays we're getting to a point where those tools are actually starting to exist. And if they're not plug and play, they're the next best thing.
Yeah, I mean, I think that on the quantum encryption side, like if you are offloading some of this work to a third-party service, then presumably that company or service is probably has more expertise and can stay on top of the industry trends and position you better for any future limitations of current encryption approaches. And then the other thing, back to your sort of public cloud example, like I imagine like in the early days of the cloud, it was completely ridiculous to think that major banks in the world would run on AWS and stuff like that. They just, from a security perspective, like they wanted to control us. But now many banks in the United States, certainly JP Morgan and many others, are, if they're not already there, they're moving in the process of moving to the cloud. So it takes sometimes a decade for some of those industries to catch up, but I think they recognize the value that the services have, and you take on so much of a burden of managing those services, and maybe not as like your core business when you're doing it yourself.
Yeah, and I think that's a big factor. So we see like the technology innovators, they're always right at the front, right? They're doing things quite early on, and that's usually pure business, like Facebook, Amazon, all of these, eBay, anybody who's just running a business and can get people to use it, or if they don't want to use it, don't have to use it, right? They're all beyond this. Like if one person is like, oh, I don't like Facebook's policies, Facebook doesn't care, right? Then you've got the finance sector, which is a couple of years behind because they've got regulatory compliance to deal with.
Mm-hmm.
Then a couple of years after that, you've got the medical sector because they've got an even bigger list of regulatory compliance to deal with. And then a few years after that, then you've got the public sector. And now in Germany, we're seeing the public sector, like finance is already like cloud first, everything fine. Medical space is going there, and we're seeing the public sector slowly moving in that direction too, because they're looking at their bills, they're looking at things. In some cases, running your own stuff bare metal can be cheaper, but in other cases, how do you find the people? And if there's like, Amazon is now opening a sovereign cloud. Lidl is opening cloud in Germany. Google has launched sovereign cloud a couple of years ago in Germany. So they're vacuuming up the engineering talent. Public sector can't compete with these pays. You can't hire these people and retain them on a public servant salary. So they're not finding the people. And then you've got, I'm going to say this quite loosely, effectively somebody who used to be a gardener running databases for like parts of the public sector. This is not going to end well, right?
Yeah.
And once that happens twice, then they're going to finally have that last little bit of a wake up that's going to push them out.
Yeah, and it's like, in the consequences of getting it wrong are quite severe. So it's not something you can afford to get wrong, and it's certainly not something you can afford to put someone who's doesn't have the domain knowledge and expertise to do it well.
Yeah.
It's kind of like historically when it came to backups, like you end up putting your junior person on backups because you're like, oh well, we need them, but we probably will never need them. So like we'll just put this person on it, and then of course when you actually do need them, that suddenly you could be losing all your customers' data because it wasn't done well, or the disaster recovery takes you weeks and you're offline and stuff. So there's huge consequences to doing that incorrectly.
The favorite one is then you're trying to do the restore, and it's like, okay, the backup is now a copy of like this kid's Metallica tape. I'm older, so like tapes is not much older, but if you don't do the restore of the backups, if you don't test any of these processes, they're useless.
Yeah, you're just checking a box saying like, hey, we do backups. We have a restore process. No one asked, did you ever test it?
And this was super common while I was at Doctorly. The doctors are all like, all right, so you've got our data in this database. We want copies of it. I'm like, I'm not giving them to you. Like, I'll give them to you when you leave. Like, if you want to go, you can have it. It's yours, right? But I'm not giving you a copy every week because it would have to be encrypted. And if I give you the encryption keys, then I don't need to pay for the secure data center because I've just sent some dude in an office an encryption key via email probably, or WhatsApp or something stupid. And it's just no longer secure anymore. And they don't understand that doing it yourself is not better.
Absolutely. How do you see this field, particularly pseudonymization, like evolving?
I really think that this is going to become another service that people can get. And you guys at Skyflow are doing it, and a couple other companies out there doing it. It's necessary. People are really starting to understand how necessary this is. Tracking of access to data, what purpose was it accessed for, who did it when, building alerting around that. So if somebody's accessing too many data points, that will trigger an alert so you can kind of see when somebody's inside your system, right? Like, because these cases where people break in with an admin credential and then this admin is randomly downloading a few databases and uploading a few gigabytes of data, this kind of thing can show up if you know what you're looking for. If you have this this filter in between your front data and your data warehouse, data storage, and it can give you really good insight into, is something wrong? And I
Yeah.
think that's going to become necessary because I said it before, we're not able to keep everybody out of our systems. We will never be able to protect as much as they will be able to attack. It's an unlevel playing field. People are going to keep finding 0 days in Windows, in Linux, in the CPUs, in the memory stacks. It's going to keep happening. And we need to be that next step ahead where everything's secured through a very good standard, but we're aware of what's going on inside our systems, and we have alerting built in that lets us know if something's going haywire. And if it is, then we can push the pause button, cut that access off quickly, and then go and look at what's going on in detail. And this is it's the intrusion detection, but then also notifying of data exfiltration. And all of this is only possible if you've got the layers in between. If most of your data is stored in a way that's anonymous or pseudo-anonymous and is not easily rebuildable, then even in the worst case, if somebody gets in and steals your database and it's generally pseudo-anonymous data, they're going to be looking at a bunch of hashes. They might have a bit of demographic data and know that your customers are between 35 and 40 in general, but they're not going to be able to do these kind of nasty things that people have done in the hospitals where they steal the data, they blackmail the hospital, and then they go out and blackmail the individuals, right? Like, I will publish your medical records of your psychotherapy, if you don't pay me. That is absolutely brutal as a crime approach, but it's happening. It's happening more often than it's reported, I would imagine.
Mm-hmm. Yeah. I think that, the easiest way to prevent the impact of a data breach is not have essentially the valuable data there in the first place, right? It's kind of like, if someone breaks in your home, maybe they are able to take some of this, I don't know, your furniture and your television, but you probably shouldn't have your diamonds and your gold just laying out on the the coffee table. Most people don't do that. They take extra steps to essentially put that somewhere where it's more protected. And then the other thing too is that going back to what you're saying in terms of you can sort of detect unnatural behavior if you're set up to detect it. And I think fundamentally the rules of engagement for accessing personal information is very different than the rules of engagement for other types of information. So if I'm a user of a system, customer support, or even a service, there are not really use cases where I need to see certain types of data or scan millions and millions of rows of data. Like, if I'm a support person, I probably only need access to maybe the half dozen people that are in my support queue at any given time. So if you understand that and those rules are baked into the system, then you can easily detect sort of behavior that's outside of that.
Yeah, and this is where I think it's going to become very much more a service-driven approach, because if we all go out and build this ourselves every single time that we need it, it's burning a lot of energy, right? This is not people's core business. People's core business is treating patients or billing for kindergartens or schools or whatever it is. If we try and build everything ourselves, we don't try and build CPUs ourselves. We don't try and build data centers ourselves. A lot of us, in certain cases, don't maintain our own cars anymore, right? Why don't we do this? Because it's better when somebody who's qualified does those things. And it gives us a certain peace of mind. In the worst case, it gives us somebody else to blame, right? And let's be honest about this. This is part of the process too. Whose fault is it? Is a question that gets asked when there's data breaches, right? And if it's the company's fault in Europe with GDPR, they can be on the hook for an awful lot of money, right? So, and that's not reimbursement. That's just the fine. That's not the individual suing them afterwards or class action lawsuits. That's just the government fining them. In America and other countries, you get a lot more of the class action lawsuit, less of the government fining. And some of the FTC and other places that have slapped organizations on the wrist, but they've really been pretty laid back about it still.
Mm-hmm.
I think that will change too. over the
Yeah.
next years.
Yeah, I think it's already starting to change. But well, Jack, thanks so much for being here. I think this was a really fascinating conversation. It was great to learn about some of the things that you've built in the past and some of the challenges that you faced and unique approaches that you took.
Thank you so much for having me, Sean. It was a lovely chat, and I look forward to talking to you again sometime.
Yeah, absolutely. Thanks. Cheers.
Bye.